Hello. Uh, can anyone confirm? Am I audible? Okay, I have enabled the chat as well. Perfect. Good afternoon. Good afternoon, everyone. Happy Teachers' Day. It's tomorrow, right? But tomorrow we are not meeting. So I have few things to discuss today with respect to Teachers' Day as well, obviously. So we'll discuss. Let's others also join, and then we will talk about Teachers' Day part as well. Tomorrow you guys have the class. Which class is going on? Shubham? We can schedule the class. That's nice of you. But other things are also there. Or so let other people also join, then I will talk about this. Anyhow, you can see the screen, but I will talk about the things which I want to discuss on the occasion of Teachers' Day. So what we have covered up in our yesterday's class, who will tell me? So majorly, we have talked about the substitution method and the recursive tree approach, right? How we can solve any recurrence relation with the help of these two methods. Perfect. Okay. So before we will start our today's session, so on the Teachers' Day, if you will see my post of yesterday's night, I'll take the doubt, don't worry. Or maybe let him talk first. Yes, Kajendra, please say.
Hello.
Yes, please say.
Good afternoon, ma'am.
Good afternoon.
Ma'am, I have a program and I am confused how to find the time complexity of this program.
Okay, so we can discuss that. Maybe at the end of the class, it would be better. Let's start the class. Or what do you guys think? We can take at the end of the class, I believe. Then if someone wants to go out of the session, he can go, and we can continue the session as of now. Okay.
Okay.
So, okay. Okay, so one simple thing which I want to talk about before starting off today's session is about the Teachers' Day. So tomorrow is the Teachers' Day, right? Everyone has already talked about. So you guys might be studying from other batches as well. There might be the students in the class who are studying for data science batch, for data analyst batch, for JavaScript bootcamp batch. I'm not sure. There are so many batches as of now, which is going on in the iNeuron, right? So it might be the case that there are, apart from me, we have started last week or last to last week, right? This batch. Before that also, I have taken so many batches. So it's just the humble request from my part to each and every student that here what we are planning is that as a iNeuron team, that the students will, if the students will be happy to give any of the video or any of the clip where he wants to tell to the mentor, whosoever is your mentor, it's not me, it's other than that as well. There are so many mentors that we have. So here, if you will open this form, you will be having an email ID, full name, right? Apart from that, okay, email is 2 times, so it's okay, you can mention 2 times. Contact number is there. After that, mentor you want to celebrate this teachers day, for example, is there, if there is someone who have studied from Krish sir, from Sudhanshu sir, from Hitesh sir, right, from Naveen Reddy Telesco Learning, from Sridhar sir, from Amresh sir, anyone. So if suppose you want to make any of the video clip, you can make, you can add that, you can upload it in the Google Drive, and you can attach either that link or you can add that file also. And if any message you want to share, so what we can do is that your video will be displayed on the YouTube channel of iNeuron, or maybe of other YouTubers as well. So that is the plan. Apart from that, either this link or maybe the iNeuron team link is also fine for us. So here also I have in my YouTube channel, this channel I have opened last month because of the request of so many students that they want to uh, learn related to AI, related to data science, or related to data structure algorithms. So these two are my core areas. I'm sure everyone knows until now that I have completed my master's in AI only. So that was the specialization for in my code area, artificial intelligence, and that I did from IIT Hyderabad. And after that, while doing the masters only, I started teaching in iNeuron as well as in Geeks for Geeks as well. So then I found very much interest in terms of teaching, and I got very positive response from the students regarding my teaching. And then I thought, I just left my own campus job, which I got from IIT Hyderabad, and I just joined iNeuron for that specific purpose, because I am also loving the teaching, and the way I am teaching, students are also loving. So there is a mutual thing which has happened here, and that's why I decided to go for this particular thing where I am getting the industry experience as well as the teaching experience, which I am enjoying a lot. So after completion of my masters, I just launched my YouTube channel also, in the thought that I will start teaching here as well. So on every Tuesday and Friday, I used to upload the new videos related to DSA and data science. Whatsoever knowledge I have, that I used to share, and that's what I like. So here, if you will observe in the community of my YouTube channel also, I have shared one link with you. So you can open this Google form as well. Either you can go for this, or let me share you the post of this, which I have. So, okay, I'm not sharing to everyone. So this is the LinkedIn post, which you can see, refer, and this is the community post, which you can refer. So either one of them, if you are interested, if you want to do something, so you can do. We are very much happy as a team. So here also, this is the another form where you can just need to mention the name, email ID, phone number, and any of your videos which you want for from any of the mentor. You should specify the mentor name as well, right? For example, if you are making the video for Sudhanshu sir, so you should mention that. For Hitesh sir, you should mention that. So whosoever videos you want to create, then you can add that file and you can submit that form. So any of the two forms, it's one and the same. Obviously, I will also give these videos if I will be able to get any videos to the main team only. And if you will fill this form, this will automatically went to the main team itself. So any of them will be fine for us. So that is the one announcement which I want to make on the occasion of that Teachers Day. There are a few more things which is happening in Aineron on the Teachers Day, but I think when people will I think at night itself on the Krishna sir's channel or on the Aineron's channel, officially so many things will be announced. So there are so many things which are going to be there for you as a student as well, which we are doing and which we are planning. So be updated, and I will for sure update everything on my LinkedIn post. So I am very much active on my LinkedIn profile. So if you will go, I used to oftenly post things whichsoever be the updated things that is going on in Aineron, whether it be related to my course. So various students used to ask to me that at what point of time you will complete your course, when is your new course will started. So there is no need to mention in the chat. If you are connected with me, and if you are online available on LinkedIn, if you used to at least at least once open your LinkedIn profile, you will be obviously see my post. So at each and every time, whenever I am starting any of the new batches, or whenever I'm launching any of the new videos on my YouTube channel or anything, I used to just share everything on my LinkedIn. So LinkedIn is my go medium to interact with all the students that I have. So approximately, I think until now, 7,000 students I already have taught. And I used to always tell them that just after the session also, it's not like that it's just a 3 months or the 6 months journey of a session. After the session also, if in future you need some sort of guidance from me, if you want to have any of the query, either you can mail me out, or you can just chat in my LinkedIn profile. That's the only two medium which I have as of now. Obviously I have Insta, I have Facebook, I have all those accounts as well, but I am not that much active. That's the thing which is there in other profiles. So that's the thing which I want to share with you, everyone. Any doubt in this part? No doubt? Perfect. And other announcements, as I told you, there are so many announcements which we will do as on the occasion of Teachers Day. Today is, I think, 4th, right? Tomorrow is the Teachers Day. So I think you will be getting those announcements very soon. Today might be because from the morning itself, I'm taking the batches. So I'm very much busy. I haven't saw any YouTube thing as until now. Might be it's already announced. I'm not sure. But if it is not announced, wait till night, or maybe tomorrow morning. Various things are going on. So you will be very much happy after that. Perfect. So this one thing, please remember, and if possible, if you have the time, please make a videos for your teachers. It will be really, really, exciting, and it feels really good. So whenever I used to see the chat window of my LinkedIn, and whenever I used to get the messages that, okay, ma'am, I got the job by studying from your course and by seeing your videos. So obviously it automatically motivates the teacher as well, right? So that's the only thing, that's the thing why we are doing so. So yeah, let's celebrate this by doing so. That's the one thing. Another thing, let's get started with the session. Okay, so until so far, yes, you can select more than one mentor as well. So what you can do is that fill the form 2 times. So one time when you are filling, you are selecting maybe Krishna, and you are uploading the video for that. Then second time, it's not like that you can select only one time, right? What to speak in video, that also I will tell to you all. Oh my God. So you need to speak about like, for example, you studied from Sudhanshu sir session. Is there anyone who is from FSDS batch? I think many of you are, right? So you studied from him. Now, so see, every mentor has its own way of teaching. I can't say that, okay, everyone is having the similar way. My way of teaching might be different. His way is different. Krishna's way is different. Hitesh's way is different, right? So what you can speak in that particular video, for example, you are selecting Sudhanshu Kumar as your mentor. So at that point of time, just think about him, that okay, whenever he used to teach, how basically he teach, what impact he makes in your life in terms of your career. For example, there are so many students I have seen, they used to tell to me that by going towards this FSGS batch, they used to gain a lot of knowledge about data science, and they easily make the transition after that. So that's the impact which that person makes in your life. Can I say that? So that is what you need to speak. You should be grateful, you should be thankful for that, you should be thankful for his guidance, because I have seen that there are so many students who will be able to make a transition after that. Similarly for the Krish sir, similarly for the Hitesh sir, similarly for the Naveen Reddy sir. So I think all the mentors in Aineron are someone who have reached to a great heights, right? So I don't need to speak anything about anyone. You all know pretty well, right? So they are famous in their own domain. So what you need to speak is how basically they have impacted in your life as your mentor. That's it, right? Yeah, Saurabh sir also, everyone. If I'm not speaking any name by mistake, there are so many mentors in this Aineron, and I think uh, as far as I have meet those mentors, I feel that vibes, that there is something inside that okay, they want to do something for the community, they want to do something out of the way for the community, and that's the right time I feel, where you can just be grateful, be thankful for them. They're not asking anything from you. Even they are selling the courses. Even if they're selling the courses, they are selling those courses in a very affordable price, that we all know. This affordability came into picture after Aineron. Before that, I remember at my time when I was not aware about this company. So I was looking for the master's thing in AI domain. As I told you, I did my master's also. And at that point of time, I was thinking that whether I should go for master's in IITs, or I should go outside the India to pursue my master's, or I should pick up some random courses. And at that point of time, when I explored those random courses, I don't want to name any company here, but those courses are of 1.5 lakh, 2 lakh, 3 lakh. I remember that. So that was the price. And even at that point of time, because I was not that much financially, it's not like that I'm not that much financially good and I can't afford that. But I also know the reality in India, that there are so many students who can't actually afford these high price courses. And even I don't know, I didn't buy any course. So I don't know that what's the actuality inside that course, like what the mentor is teaching, and is there that much depth the way they are demanding their money. I'm not sure about that. But whatever I know is that these courses are of very huge prices. And after that, when this I came across for the very first time, at that point of time I was in my masters, and I saw that these courses are of these data science courses are of 15,000, 17,000. I was quite amazed. I was like, either the quality was very bad. This was my first perception about the Indian. I am frankly saying to everyone that either the courses are very bad, the quality is very bad, or maybe they are not teaching everything whatsoever they are writing in the course curriculum. But when I just came across, I got the access of the courses. I just see the courses after joining the Aineron. And before also, I was in a way doing the part-time job with Aineron. I am associated with Aineron from past 2 years. So I was getting the access of those courses. And when I saw those courses, it's like unbelievable for me. Clearly, it's unbelievable for me. So that's why I am saying that yes, it's a blessing for all of us, and we should appreciate that. Whatever be the reality, it's the reality, and we can't deny that. We should appreciate those things, right? Okay, perfect. Now All the logistics are done. Now let's start our today's agenda. So basically, as I told you that in today's session, first of all, I need to discuss about the properties of that logarithmic, right? As far as I remember. So let me close my camera because it is actually displaying in my screen. So I feel very less screen. So here, let's talk about the properties of the logarithmic. After that, we will discuss about the homework problem that I gave to you. And after that, we will talk about the master's theorem. Let's try to complete these three things first. And after that, we will see if time permits to us. We will also go towards the array data structure. Otherwise, we can start the data structure in the next class. Okay. So I think whatsoever we have discussed all the basic properties, but still I am writing there because many students have requested. So the basic properties that everyone should know regarding logarithmic in DSA, I'm writing here. Basic properties of logarithmic. The very first property that I think now, as far as I know, everyone should know is, suppose I am saying a to the power x, which is equals to n. So can you tell me what is the value of x now? Who will tell me? What is the value of x? It will be equals to, I am getting the correct answer, log of n base a. I think this we have done now a lot of times. How? Basically, if you will observe, this is what I used to do, right? Maximum number of times when I used to say to you that just take what we need to do is that. Can anyone tell me? So when we take log base a on both of the sides, what will happen? Log base a to the power x, which is equals to log base a n. Now, x can come up front and log of a base a will give 1. So that's why we will be able to get this first property like this. Second important thing that everyone should know regarding logarithmic is that whenever we are talking about log 1 base of anything, base b, suppose, it is equals to 0, right? So this is the second property. The third important thing that everyone should know is that log of, suppose I am saying a, base is also a, it is equals to 1, right? Everyone knows until now that whenever our base is same and the value is same, they will cancel out with each other and give the answer as 1. Next, property number 4. Whenever you will be having a value log base a, p divided by q. Anyone knows how we can split this thing? So whenever you will be having a value which is in the division part, yes, it should be. So you can write it as, so it can help you in splitting this thing. So you can write it as log base a p minus log base a q. This is the fourth important property that everyone should know. So whenever the value is in division, you can write in the form of a subtraction. Perfect, everyone? Next property. Now, suppose I am saying log base a p into q. Who will tell me? If suppose I want to do the split of this, so it is something which is equals to, very good, log base a p plus log base a q. This is the next property that we have, right? Property number 6 that you all know, I think, log of base a p to the power n. Suppose I am writing like this. So I can write this number as, who will tell me? We can write this as, we can take the power up front. Log of, sorry, n of log p base is a, right? Now, next important thing, property number 7. Suppose I am writing like this, a to the power log of p base a. I can write this as, who will tell me? P. Very good. How? Basically, here if you will observe, what we can do? What we can do? We can replace, interchange this P and this A. So what we can write it as? P to the power log of A base A. And we all know that this particular thing can be 1. So it is equals to P. So that is the property number 7 that everyone should know. Okay. Property number 8. Log of n, suppose base is A. This can be written as log of n base B multiplied with log of B base A. This is another property. Means you can write any of the logarithmic thing in terms of different bases. How? That's the thing. So you can write like this. Log of n. Point number 7 is saying that A to the power log of A, log of P base A can be written as P. How it can be possible? So we can interchange this value of A and P. Or in other words, if you want me to do further calculation step by step, what we can do is that log of P base A. So what you can do? You can maybe take the value of log of P base A and you can take log of, so here A become as it is. We can take the power up. Is it fine, everyone? So what I'm saying is that this base and this coefficient, what we can do is that we can do the interchanging of these two. Now we know this property, right? Where the value of log of A and the base A, they can be equals to 1. So anything to the power 1 is equals to P. So they are both interchangeable with each other. That's why we're getting the value as P. Getting my point, Hamid? Basically, we can interchange. So just like the way in the above case, what we talk about, that we can take the, where is the value? This is the thing. We can take the power up front, then log of base A into P is there. Here what I am saying is that whenever you will be having any of the values with respect to the log, what you can do is that you can interchange that value with the base which you have. This coefficient can be interchangeable. So if it is interchangeable, P can come below. It will be log A base A. And the value of log of A base A is 1. So it is equals to P. Property number 7 says this. Property number 8 says that if suppose you want to, suppose the value of A is equals to 2 and the value of B is equals to 3. Okay. So what I'm saying is that suppose you want to write your logarithmic in terms of the base 3. So how you can do that? I am saying that the value of log of n base 2 can be written as log of n base 3 into log of 3 base 2. So this can be split into this. Why? Because this base value and this coefficient value will be same. This is what you need to make sure, that the base value in the first part and the coefficient value in the second part should be same. So you can write like this. Is it clear, everyone? Property number 9. This is the last property which I want to discuss and which will be helpful in our courses. Log of B base A. This can be written as, now again, suppose you want to write in terms of base n. So how you can write? Log of B base n divided by log of A base n. So in terms of different bases, you can write in terms of division. So log of B base A can be written in terms of division by saying log of b base n divided by log of a base n. Property number 9. Is this clear, everyone? For example, I am saying that a value is again 2, b value is 3. So you can write log of 3 base n divided by log of 2 base n. This will be one and the same thing. So these are the some basic properties of logarithmic that we have used in our sessions so far. And this is the only thing that you should know. Right? Is this fine to everyone? Any doubt in any of the property before I will move ahead? Correct? So someone is talking about the graph of the logarithmic. In 8th, we didn't have B. Where is B is here, no? So it's simply indicating that if you want to change your base to some other base in terms of other base, so what you can do is that you can split it down into two parts by writing like this. Here B can be any constant, A can be any constant. Who will tell me the graph of the logarithmic? How it usually looks like? Suppose this is the x-axis and this is the y-axis that we have. What should be the graph of the logarithmic? How it will look like? It is something like this. I don't know. My drawing is something like this. So here it is indicating y is equals to log of x. So your graph will always be looking like this. And the series of logarithmic we already have discussed in our yesterday's class. What is that series? What is the log series? GP is different thing. What is log series? Who will tell me? Yes, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 until the value of 1 by n. That is something which you can say is a logarithmic kind of a series that we have. Fine? Perfect. So this is the one thing that we need to complete today. After that, let's talk about the assignment problems. So let's discuss that first, and then we will talk about the master's theorem as well. Perfect. Let's start from the yesterday's session. I have given you 3 problems in the yesterday's class. I hope I am saying it correctly. So DSA live batch, lecture number 3. Correct. So here, if you will see, the very first problem was this one. So is there any doubt in this problem? Is everyone able to get the result as n log n? Perfect. Let's talk about problem number 2. So wherever you are facing the difficulty, that problem I will solve. If maximum students will be able to solve that problem, obviously we need to, take the next upcoming syllabus as well. It's not like that we need to just have analysis portion in our batch. We need to talk about other data structure algorithms also, right? Second problem that we have was, yes, related to recursive tree approach. Let me check the answer of this problem and then I will ask from you. Let me check once. This is the problem. Yes, what answer you guys are getting for this problem? Anyone? Order of n. Order of n. Let me check once. Okay, So it is something you should get as yes, n to the power 1.5. Pranjal, I think, can you come unmute yourself, Pranjal? Can you raise your hand so that I will give you the permission? And can you discuss your approach? Yes, please.
Hello.
Yes, yes. Please say. I think your approach
Hello.
should be correct by seeing just the answer, but let's see. Yeah, please tell.
Yeah, audible.
Yes, yes, you are audible. Just be
So,
little close with the mic.
So basically, my approach was that I have taken the n and then divided into the left, middle, and the right side. Means left
Perfect.
side is 1/2, middle part is 1/3, and the right side is 1/5. And
Perfect.
the first case, we have the this what constant as c.
Mhm.
So this constant will be throughout for like for the first level we have n/2, n/3, and n/5. So
Perfect.
corresponding to n/2 we have c.
Hmm.
Corresponding to n/3 again we have c,
Hmm.
and corresponding to n/5 again we have c. So that will be 3c. So
Everyone, please listen the approach very much carefully. The way he is explaining is perfectly fine, right? And then after that, you can ask the queries. Yes, please.
now
Okay.
this is the first level 3c. Now we
Perfect.
will be going to second level. So
Hmm.
now second level, now we will be considering for the part n/2. So again n/2, three divisions will be there.
Yes.
So again n/2 left side will be divided by 1/2. So that will be n/4. So middle
Yes.
part will be n/8, and the third part of n/2 will be n/10. So for this
Exactly.
part only we have 3c. So we have
Exactly.
three parts. So we have three matlab means total will be 9c. So
Perfect.
we can matlab we have just gone to only two levels, and we have got the idea that yes, it is something forming like three power something. So like in
Yes.
the first level we have 3 power 0c. The first in the first level we have 3 power 1c. In the second level we have 3 key power 2c. So we have got an idea that yes, it is a gp having a common ratio of 3. So we can
Perfect.
just, as you have explained in the previous class, that this is not a case of the constant this c case like n we have.
Exactly.
So we will be
Exactly.
summing up to k terms, and we will be finding the k value by just simply putting n/2 की power k equals to 1, n/3 की power k equals to 1, n/5 की power k equals to 1. So there
Perfect.
we get the value of k as log n to the base 2. That is a maximum. So putting those values
Perfect.
and then neglecting the this one constant terms, we got the as o n log n की power log 3 by n की power log 3 to the base 2. So that is around 1.5. So after 1.58, that is
So here you are getting a GP series, right? And
yes,
when you solve that GP series, you are getting the value as n to the power 1.5.
yes.
Perfect. Yes, it's perfectly correct. Whatever approach Pranjal suggests, great Pranjal. It means that whatsoever I have explained in the yesterday's session is pretty much clear to you.
Ma'am,
Perfect.
but I'm not able to get. I have got a crystal idea of this recursive tree approach, but I'm not able to get about the idea of the this substitution method, because I have tried to solve the previous question also, but I'm a little bit confused. Means I'm not getting the log n term in that.
Okay. Let's talk about that also with another student who solved that.
Okay.
Okay. So the second question, I think the recursive tree approach thing, is that fine for everyone? So basically, if you will try to observe here what is happening, what was the problem? So the problem says T of n is something which is equals to n by 2 plus, sorry, T of n by 2 plus T of n by 3 plus T of n by 5 plus C, right? So here, if you will observe what is happening, we are splitting our data n into 3 times, n by 2, n by 3, and n by 5. And the cost required to do the split is C. Now here, when further split will happen, it will be something which is equals to again n by 2 to the power 2, n by 2 into 3, n by 2 into 5. Similarly, here also 3 splits, here also 3 splits. At every split, the cost requirement will be C only. So in the next level, what is the total cost? It will be equals to C plus C plus C, 3C. In the next level, what will be the cost? It will be equals to 9C, because in total we will be having a 9 values. Because this is the value which is given to me. That's why. In the recurrence relation, it is given to me. That's why I am writing C. So for when I am splitting the value of n into 3 parts, it is given to me that it is equals to the cost required to do the split is C. How 3C is coming? Because at the next level, when you will do the split into 3 parts, right, like this. So here what you will do is that you will add these terms. So in the next level, it will be equals to C plus C plus C. So it will be equals to 3C. Yes, cost will be the term independent of this T parameter. This T parameter is a recursive term. And C is something which is not dependent on that. It's a constant function that we will be having. Similarly, when you will do the split further here also 3 splits will happen, something like that. So what you will observe is that in the next level, it will be equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, we will be having a 9C. So here, if you will observe, there is some pattern which is coming on. It will be nothing but is equals to 3 to the power 0 into C at the first level, 3 to the power 1 into C at the second level, 3 to the power 2 into C at the third level. Now the question is that how many number of levels should I go to add all the cost to get the final time complexity part? So what will be the value of K? Now here you need to find out the 3 K values. One is for the left side, one is for the middle one is for the right side. For the left side, if you will see, you are keep on dividing it by 2, so it will be n by 2 to the power K, which is equals to 1. So n will be equals to 2 to the power K. So the value of K will be equal to log of n base 2. The value of K will be equals to log of n base 2 on the left side. If I will talk about on the middle part, you are keep on dividing it by 3. So it is nothing but is equals to n by 3 to the power K, which is equals to 1. So the value of K will be equals to log of n base 3. Now you all know the logarithmic properties as well. So I think it is very much easy to understand how I am writing it as log of n base 3. Similarly, on the right side, if you will see, we are dividing it by 5. So it will be n by 5 to the power K, which is equals to 1. So here the value of K will become log of n base 5. This is the third value that I am getting. So value number 1, value number 2, value number 3. Now the question is, which one is having a higher level? Again, another property which I will refer here only. So this is the property number 10th. Let me write it here. Always remember, lower the base in logarithmic. Lower the base in logarithmic, higher the value. This I already discussed a lot of times, but let me write it one more time here so that these notes are with you, and whenever you're referring, you should be able to revise these concepts. So here, if you will observe, this is having a lower base, right? Log of n base 2. So this is something which is having a higher value or higher level. Can I say? So if this is having a higher value or a higher level, so you can write the value here as log of n base 2. So C, I can take the common value because C is common to everything in this series. So it will be 3 to the power 0, 3 to the power 1, 3 to the power 2, until the value of 3 to the power log of n base 2. Log of n base 2. Now again, if you will observe, this is something which you can say is a GP series. With the common ratio R value is equals to 3. Can I say, everyone? Because here if you will see, 3 to the power 1 divided by 3 to the power 0 is something which we are getting as a value as 3. Is this fine to everyone? Any doubt until this part? Now, what is the value of A? The value of A is something which is equals to 1. Now, what you can do is that you can apply a GP series formula, sum of GP series, where the value of R is greater than 1. So it is something which is equals to, summation will be equals to A into R to the power n minus 1 divided by R minus 1. So here C will be as it is. C will be as it is. Inside that, what you can do is that, what is the value of A? It is 1. What is the value of R? 3. What is the value of n? Number of terms. It is nothing but log of n base 2 minus 1 divided by 3 minus 1, which is equals to 2. Solve this. Now you know the properties also. Now you can't say you don't know the properties. Just now, few minutes back, I have talked about property number 7th. Where I have just told you that this A and P can be reversible. Just now I told you. So if I will use this property number 7 and just interchange the value of this 3 and n, what I will be able to get? C into n to the power log of 3 base 2 minus 1 divided by 2. Just I have used the property number 7th, which I have just talked about. Property number 7. So here this value is something, log of 3 base 2 is 1.5 approx. So here this is something which will be n to the power 1.5. And remaining things are constant only. So the time complexity in terms of big O will be n to the power 1.5. Ask me the doubts if you have. Fine. So first, this was the second problem. First problem was, who will give me the first problem? So first problem of the substitution method was, if 1.5 is not available, you can mention n square. Yes, perfectly correct. So here, if you will see, 2t n by 2 plus n. Okay. 2t n by 2 plus n. When the value of n is greater than 1. And when the value of n is equals to 1, it is equals to 1. So who got the correct answer? N log n. Who will tell me the approach? Just like the Pranjal suggests the approach in a very correct manner. Who will tell me this approach? Number of divisions is same as number of recursive terms. What does that mean? Yeah. this number of divisions that we are doing is same as the number of recursive terms that we have. Correct? Yes. Who will tell me this approach? Yes, this question we solve with the recursive approach, but by using substitution method. How we can do so? Who will tell me the approach? See, if explanation part is also I am doing, and assignments also I am solving for you, then what you guys are doing here? Tell me. If suppose I am giving you the assignment and that also you want me to do, right? And the actual questions while giving the explanation of the concepts, that also I am doing. So is that only the thing which I will do here in this course, or you guys will do something for me? Yes, Pranav, tell me the approach.
Hello, can you
Yes.
hear me?
Yes, yes.
So the approach will be like first we will find T of n by 2.
Then
And then we will put that value of T n by 2 inside this function T of n.
so what we will be able to get as the equation?
So the equation will be 2
Hmm.
and one bracket and then 2t.
Hmm.
2t of n by 2 square
Hmm.
plus n by 2
Very good.
and close the bracket, then plus n.
Perfect.
Same way, we have to find out the value of t n by 2 square.
So can I write, just wait a moment.
Yeah,
Can
yeah.
I write this equation like this? 2 to the power 2, t to the t by n by 2 to the power 2 plus n by 2 plus n. Everyone? Can we write like that?
No. So we have to multiply 2 into n by 2. So 2
Yes,
2
so it will
get
be n.
cancelled. Yeah.
It will be n. Yep.
Yeah.
Correct. Can you write like this? So what I did is that I just take this 2 inside this. So it will be 2 to the power 2, t of n by 2 to the power 2 plus, if we take 2 inside, so it will be 2 into n by 2, which will be n plus n. Yes, move ahead. Next step.
Yes. Next step, to simplify further, we can also write 2n in the last for this equation.
Yes.
And then we will substitute the value of t and of n by 2 square. So that will become 2 square open bracket 2t n by 2 cube
Exactly.
plus n by 2 square
Perfect.
close bracket plus 2n.
Perfect.
Now similarly we can simplify this equation too, and this will become 2 to the power 3 t n by 2 cube plus 3n, right? Now we got the pattern of with the three step only. Now we can go furthermore with a step of k and just replace 3 by k, and we will get what the equation look like when we reach the kth step. So it will become 2 to the power k
Perfect.
t of n by 2 to the power k
Perfect.
plus 3k.
Plus k into n.
Yeah.
Perfect. Now what will be the value of k?
Now as we can know, like the base condition was like we have to make n by n equal to 1. So that will be 2k is equal to n.
So it will be n by 2 to the power k, which is equals to 1. Correct?
1. Right.
So n is equals to 2 to the power k. So k is equals to
log n.
Log of n base 2. Perfect. So now if we will put this k value in this equation, Correct?
Right.
Now,
Now, like with this step, we can also do like simplify it. So in the previous step, we have 2k and t of n by 2k. So we know t of n by 2k will be 1.
okay. So how it will be 1? Let me simplify it more. So here, if you will see the below equation, 2 to the power log of n base 2. So again, n and 2 can be interchanged with each other. Property number 7. So here, if you will see, what we can write it as n divided by n to the power log of 2 base 2, right? And here also what you can do is that interchange the value of n and 2. So it will be n to the power log of 2 base 2 plus log of n base 2 into n will remain as it is. Now here this value will become 1. And now n divided by n will become 1. This will become 1. So what we will be able to get, n into t of 1 plus log of n base 2 multiply with n. Here, this value of t of 1, we also know. What is that value? T of 1 is something which is equals to 1, right? So n into 1 is n plus n into log of n base 2. Now, remember the complexity classes that we have discussed. Which one is bigger? N is bigger or n log n is bigger?
N log n.
N log n is bigger. You're multiplying something with n more than n. So it will be n log n, which is bigger. So in big O, we used to take the bigger term. So it will be big O of n into log of n. If you mention base 2, it's fine. If you don't mention, then also it's fine. But the approach should be clear to everyone. So Pranav, good job. He also suggested the way he told the approach is pretty much, I'm happy with the approach. So before also, I think there was some student who talk about the recursive tree approach. He's also saying with everything very nicely, the way I used to tell to the students. And I think now I am feeling very much satisfied that at least there are students who are learning things in a good way in the class. Yes. Any doubt? Yes, Radha.
Yeah, ma'am. So just can scroll up. I just had one doubt regarding the substitution throughout one step. In every beginning step, like we substitute this thing, right? Whatever is present, it's at a t of value. While doing that, for example, if you take this itself, n by 2 is replaced by n by 1. We multiply again n by 2, right? So the last step, y again plus n, we are doing that. Adding
Where plus n?
on the top itself, the first step we are substituting.
So here we are substituting the value of t of n by 2, right?
Yeah.
In this equation, this is the standard equation that we have. In
Yeah.
this equation, we are substituting the value of t of n by 2. So
Correct.
this t of n by 2 is substituted in this bracket.
Yeah.
Plus n will be as it is, right?
Like if you take
Plus n was there in the above equation. So that we have directly put as it is there. This 2 was
Okay.
also directly as it is there.
Yeah.
What we did is that we just substituted the value of t of n by 2. That's it. Again, if you will go below, this is the equation. Here, if you will see, we have just substituted the value of this in this particular bracket. Remaining things will be as it is.
Okay.
From the above equation, we are taking up. That's it.
Okay. Yeah. Okay.
Right?
Yeah.
Okay. What was the question number 3? Which I gave to you all? I think that was also related to the substitution method. Yes, T8 n by 2 plus n square. Who will tell me the approach? First of all, tell me the answer. 8t n by 2 plus n square when the value of n is greater than 1. When the value of n is equals to 1, it is something which is constant. Let me verify it once. If I have the solution of that, otherwise I need to solve it. Yeah, I got the solution. Yes, what is the answer you guys are getting? N cube. I think it's a correct answer. So who will tell me the approach for this particular question? 8t n by 2. Divyanshu? Radha, you can unraise your hand if your doubt is resolved. Divyanshu, do you have any doubt? Or do you want to tell the approach? Ankan?
Good afternoon, ma'am.
Good afternoon. Yes, please tell the approach.
Actually, here at first we are replacing the Tn by 2. In the next step, we are going there, and here we get 8. Yeah.
So when we replace the t of n by 2, what we will be able to get
We are
inside the bracket?
yeah. Then 8t by multiplied by n by 4.
Yes,
Yeah. Plus n by 2's whole square. We are getting.
very good.
And then we are getting plus n square. Then when we actually simplify this step, we are getting actually it's something like 64t, 8 square t, then n by 2's square, and then it's like 3n square plus 3n square. It's like that.
Okay, so it will be n square by 4. So if you will see everyone, 8 into n square by 4 plus n square was as it is. So it will be 4 to the 8. So 2n square plus n square, 3n square. That's why he's saying 3n square as a direct after solving the calculation. Okay, let's move ahead.
Then we are again on the third step. We are again replacing the 2 of n square, n by 2 square. We
Perfect.
are replacing that, and it's something like 8t with n by 2 cube.
Perfect.
Plus n by 4's whole square. We are getting again. Yeah.
Perfect.
That's right. Yeah.
Plus 3n square as it is.
3n square. Yeah.
Now, when we solve this equation, what we will be getting?
We are getting somewhat like 8 cube t. N by 2's cube plus 4n square plus 3n square by this resolving, and when we
7n square.
it's 7n square actually.
Perfect.
Uh,
Okay.
So
how we are getting this 4n square? So let me take it inside. So it will be 8 square, which is 64, n square divided by 16, right? So
yes.
here, if you will solve this, it will be 4. So that's why it is 4n square plus 3n square was outside. So it will be 7n square. Okay, let's move ahead.
So just looking at the pattern, we can tell it something like it's 8 to the power k t multiplied by n by 2 to the power k, and then plus 2 to the power k minus 1, not k minus 1, is 2 to the power k and then minus 1.
Like this?
Yeah, yes.
Okay.
And then n square.
Okay.
So if we just resolve that n by 2 to the power k is equal to 1, so we will get like k is equal to log base to n. And if we put the value of k in there actually, so it's something like that would be resolved to 1, that t's function. And also we can write 8 as 2 to the power 3 to the power log 2 n, log base to n actually.
Yes. So basically, this particular thing, if you will observe, again, if you will apply that property number 7, so 8 and n can be interchangeable. So you can write it as log of 8 base 2. And if you will see log of 8 base 2, if you will solve, this can be written as log of 2 to the power 3, right? So 3 can be upfront. Log of 2 base 2 is 1. So log of 8 base 2 is having value which is equals to 3. T of n by n can take upfront again log of 2 base 2 plus again here also you can take n upfront log of 2 base 2 minus 1 into n square. Now here what you can do is that you can write it as n cube into t of n by, it will be 1. So n by n is 1 plus it will be again 1. So if I will take it inside, n cube minus n square, right? And this value is t of 1 is something which is equals to 1. So it will be n cube plus n cube minus n square. So which is having a higher exponential?
N cube.
N cube. So it will be big O of n cube. Perfect, Duncan. A good job. So the approach, whatever he suggested, is perfectly fine. So that's what I am looking for. Your approach should be correct, even though maybe in between calculation, you might do some mistake. That's completely fine. But the way the students are telling the approach, I'm quite happy with that. Right? Clear? Good. Okay. So, all set. So here we have did the discussion of the assignment problems of yesterday's class. Now, day before yesterday means on the last class, I have given you the problems of big O time complexity as well. Let's talk about those problems as well. And let's see who will give me the correct responses. Let's discuss about that part. I think that was in lecture number 2. Let me close the previous PDF now. Okay. So this was the complexity classes where we have talked about big O, omega, and the theta notation, right? Perfect. Now let's talk about the practice problems of this class. The very first problem says, the value of f of n is n minus 10 and g of n is n plus 10. Let me write it. F of n is n minus 10 and g of n is n plus 10. So can we write the value of f of n is theta of g of n? Yes. First of all, tell me true or false. Let me check if I have already solved it out. Otherwise, I will solve it side by side. Where is that question? N minus 10, n plus 10. Yes. I got it. So the answer should be true. The correct answer is true. So those who are saying false, can you raise your hand? Those who are saying false. Let me discuss why they are saying false. Here, when we are talking about theta notation, so what is that approach? Whenever theta is there, who will tell me what is the approach? It means that whenever we are saying theta, it should satisfy that big O, and it should also satisfy the omega. Correct, everyone? So here, let's first of all work for big O. Big O says that the value of f of n should be less than or equal to c times g of n. So n minus 10 is less than equals to c times n plus 10. At what value of c this will be satisfied? right? With the value of 1 itself, I think this equation is satisfied. So this is for sure that this equation f of n is satisfying the value of, why this is happening? Let me close this. So f of n f of n can be written as big O of g of n. This is for sure. Now let's talk about covering up the omega part. Right? In omega, what is the equation? F of n should be greater than equals to c times g of n. So n minus 10 greater than equals to c times n plus 10. So is there any constant c for which this equation will be satisfying? No, is it so? These are some constants, right? Plus 10, minus 10. If suppose you will take for, again, remember my point. When I was saying these type of questions, we are dealing with the large values of n. So never ever go for a n value as 1, 2, 3 here. So if I will write the value of c as 1 by 2 only, automatically the value will become half. For example, I am saying that the value of n is suppose 1000. See this? If I will take 1000 minus 10, approximately you will get the number as 990. And here you will get 1010 divided by 2. Automatically for the very high value of n, this number or this value on the right hand side will become very small. So this LHS will become very high at this constant value. So at that point of time, you can write the value of f of n as omega of g of n. And because you can write in both of the sense, that's why it can be written as f of n as theta of g of n. Don't work for small values of n. We are here working for only the large values of n, because we are dealing with the large data, not the small data. So always whenever you are solving the problems related to the time complexity part, always think of the large value of n. Then only you will be able to approach towards the right solution. Otherwise you will get confused. Getting my point, everyone? Any doubt? Here, if you will see for the large value of n, I have given you the example also. When you write this value 1 by 2, automatically the left hand side value will become higher as comparable to the right hand side value. See this? So 1010 will become 505. Right? And here I am just taking the number as 1000. Usually we are dealing with a very high numbers. It is like in MB and TBs nowadays. So at that point of time, obviously you can, with any constant like this, you can satisfy the above equation. That's why you can write the value of f of n as theta of g of n. C should be constant which is greater than 0, not equal to 0. Okay? Greater than 0. Fine, everyone? What was the next question? What was the next question? So the second question says, okay, both of them are n. So what was the answer? It is very simple. It is very simple. I don't want to discuss this. F of n is n. So if someone is not aware about this particular part also, I'm sorry, it means that you need to re-watch that session. Can we write f of n as theta of g of n? Who is saying the answer as false? Only those people raise the hand. Those who are saying that the answer should be false, please raise your hand. I want to talk with them. Anyone who is saying in the class that the answer is false? No one? Okay, then I feel it is quite easy, right? So the answer should be equals to true. Answer should be equals to true here. Why is that so? Because when you will put the value of C as 1 itself also, then also you will be able to satisfy both of the equations for the big O as well as for the omega. You can check at your home. It's quite easy. I don't want to waste much time on this part. Let's talk about another question. Question number 3. Okay, so here this question requires a little bit knowledge of the logarithmic part. If you're good in that, it is also easy. 64 to the power. So let me talk about question number 3. Can anyone speak for me? Can anyone raise the hand and speak for me this question? Or what I can do, maybe I can take it on another screen. Now it is fine. Okay. So the question says 64 to the power log of n base 2 into 32 to the power log of n base 2. Can we write it as order of n to the power 5? Who will tell me the answer? First of all, whether it is true or false. It is false or true. Let me check it once with my end. Then we'll see the answer from your end, if I will be able to find. So the answer says to me that it is false, but people are saying true also. False or true? Somewhere true is coming, somewhere false is coming. Okay, how many people are saying true? Raise your hand. True people, raise your hand. Only one student in the class? 2 students? Oh my God. I am seeing that in the chat window, there are so many trues there. Now only 3 students are raising the hand. Now, please focus here and try to see that why it is false. Answer is false. See here, we can solve this thing. Now everyone knows the properties. I am blessed that I told you about the properties now. At least you can't say that you don't know the properties now. At least now you guys will be able to understand what I am saying here, right? So 64 and n we can interchange with the help of property number 7. So n to the power log of 64 base 2, right? Similarly, this thing also, this is n to the power log 32 base 2. We can interchange n and 32, right? So log 32 base 2. So if I will solve this, let me solve separately this log 64 base 2 here. If I will solve this, I will be able to get the value as log base 2, 2 to the power 6, right? So 6 is the answer, correct? If I will solve log of 32 base 2, so it will be log of 2 to the power 5, base is 2. So it will be equals to 5. 5 is the answer. Correct, everyone? So it means we will be able to get the value as n to the power 6 into n to the power 5. Can I write? And if the base is same, I hope everyone knows the base is same, power can be added. So can I write like this, n to the power 11? Is everyone agrees with me on this note? Now, when we are saying big O, the equation says f of n will be less than equals to c to the power c into gn. That's the thing, right? Now, we will be having n to the power 11. That can be written as, can we write something here which will satisfy this equation? Which will make this equation, means which will make the value of the right hand side to be greater, right? That is the equation of big O, right? Now, those who are saying true, might be you guys are doing one mistake. You are saying to me, I am assuming, let me know that what's the reason of saying you guys are saying as true. Might be you are saying or considering that constant c value as n to the power 6. And if you are doing this, you are doing a mistake. If you are doing this and saying to me that if you will put the constant as n to the power 6, and you are saying that it is true, you are doing a very big mistake that we already have talked about in our live sessions. What mistake we are doing? Many students already did in the chat window, that we have discussed that C should be constant, not dependent on any of the n factor. But here, if you will see, C is dependent on the value of n to the power 6. So if the value of n will be increasing, the value of C will also get increased. If the value of C will decrease, the value of C should also be decreasing. So here, in a way, C is dependent on the value of n, which we don't want. That's why this is not a valid big O. So you guys usually say, give me the examples of the false thing. So this is a false thing. Very big no, very big false. N to the power 6, how much dependency is there? You can see. Any doubt? Anyone? Those specifically who said the answer is true, right? Are you able to understand your mistake? Doing mistake is not a big issue. Everyone at some point of time used to do the mistake. But getting something learn out of that mistake is important. So are you learning, those who are doing any kind of mistake in the assignment or practice problems? Fine for everyone? Shall we move ahead towards the next problem? So what was the problem number 4? Okay, I have on the other screen. Okay, problem number 4, as far as I can see, is equals to 4 to the power n, 2 to the power n, which is equals to big O of 2 to the power n. Yes. Second also explain why you are confusing in second. It's very simple. F of n is less than equals to C times n. C times n when we are talking about big O, right? So what is the value of C that we can put here? C will be equals to 1. Satisfied. So big O is satisfied. Now when we talk about omega, n should be greater than equals to C times n. Again, if you will put the value of C is equals to 1, this omega will also get satisfied. If both are satisfied, this equation will get satisfied. That's the simple thing. Right? Okay. Question number 4. Who will tell me? True or false? Anyone who is saying false? So 2 to the power n is something which I can write like this. Right? Now, is there anyone who will tell me the false? This equation is false. I want to talk with that guy. Anyone in the class who will say no to this equation? Or everyone is supports true? We can clearly see, right? Now I think it's very easy. So here this will be cancelled out. Big O means less than equals to C times 2 to the power n. Here also we will be having 2 to the power n. By putting the value of C as 1 itself, we will be able to satisfy this equation. So yes, this is true. Very simple. See, when we know the fundamentals to be very much clear, when we know the basic properties of logarithmic, you can easily see things become very easy. Right? Let's talk about question number 5th. I hope no one is having doubt in this question, right? 5th one is the last question, I believe. So let's talk about that. 128 to the power log of n base 2 into n square, which is equals to theta of n to the power 9. Perfect. So 128 meaning 2 to the power 64 to the right, 2 to the power 7. Okay, perfect. So what is the answer you guys are getting? Anyone who is saying false to me? Please raise your hand, those who are getting the false answer. I want to discuss that approach. There is someone called Tiwari ji. Let me unmute him. Yes, please tell your approach. You are getting false answer.
Yes, for the omega case.
Okay, how? So let me solve this question now. So here n can be taken upfront, log 128 base 2 into n square. So
Yes.
this can be written as n log of 2 to the power 7 base 2 into n square. Can I say?
Yes. Yes.
Right? So
Yes.
what we can do is that we can write it as n to the power 7. Log 2 base 2 will become 1 into n to the power 2. So it will be equals to n to the power 9. Can I say?
Okay. Actually, I missed that power 7. That's why.
Okay. So you got your mistake.
Yes.
What about others? Who got the answer as false? Everyone got the mistake? If there's someone who did the mistake? So now here, if you will see, we will be having n to the power 9, which is equals to theta of n to the power 9. Now here, what we can do is that we can completely check. Again, similar kind of thing. N to the power 9 less than equals to c times n to the power 9 for big O. N to the power 9 greater than equals to c into n to the power 9 for omega. Omega and big O. With the c equals to 1 itself, equations are satisfying. If it is satisfying, we can say f of n is equals to theta of g of n. Where what is f of n? This is f of n. This is g of n. Any doubt? Anyone? I think now it is very easy, right? Those who was having any sort of doubts, I hope that with the discussion of these assignment problems, whatsoever things we have covered up until now with respect to the analysis module, you all got some sort of revision with the help of this. Those who got all the answers correct, it's very good. Means you're learning a very apt thing from these live sessions. Those who did mistakes, I hope that they will be able to get the clarity that, okay, where I am doing wrong and how will I improve in future. These things will help you, right? So let's talk about the last portion of our analysis. And after completion of that master's theorem part, our complete module of analysis will be completed. And I hope that you really enjoyed the module that we have covered up and you really get the confidence now for the future sessions, where now we will actually move towards the actual data structure and algorithms part. Then we will see that whatsoever things we have studied so far, it might be the case it is not making sense to you because we are not touching as of now any of the code. Until now, we haven't touched anything related to the coding part, right? We are just talking about the time complexity, space complexity, recurrence relation solving methods, all these stuffs, specifically a priori analysis part, right? So now all these things will start making sense to you when we will start touching upon the actual data structures part from the next week. But before that, let's complete our remaining pending portion of the master's theorem. Shall we start now? Perfect. Everyone ready? Master's theorem is quite helpful for all of us. And that's why I want everyone to be very much conscious now in this session as well. This requires lesser understanding and more practice. This theorem requires lesser understanding and more practice. So let's talk about that. And I think after that, we can end our today's class. So let's talk about the last part of our today's session, which is about the master's theorem. And this is the last method to solve any recurrence relation. Okay. First of all, the question is that where this master's theorem is applicable. This master's theorem is applicable only to this kind of a recurrence relation. Whenever you are facing T of n, which is equals to A T of n by B plus f of n. Give me just 1 minute. Yes. So the master's theorem is applicable only to those situations whenever you will find this kind of a recurrence relation. A of T of n by B plus F of n. If you remember, today also we discussed one example where we have seen 2T n by 2 plus n square, right? We solved one example, something like that. So these kind of questions where you will be having some value of A, you will be having some value of B, and you will be having some function f of n. At that point of time only, this recurrence relation will be applicable. I hope I'm audible, right, everyone? Yes, perfect. So here, okay, this is fine. Now we got this particular thing. Now the question is, what is this f of n? This f of n is the function whose value is something which is equals to theta of or big O of n to the power k log of n power p. Okay, this is the value of this function f of n. With the help of this value, you need to find out what is the value of k and what is the value of p. For example, if I will give you this recurrence relation, which I have mentioned in the green marker, and if I will ask you, can you tell me what is the value of a in this equation according to the equation which you are seeing in the above case? Who will tell me what is the value of a? What is the value of b? What is the value of k? What is the value of p? So these are the four values that you need to calculate whenever you are doing a master's theorem, given any recurrence relation. So here, if you will observe, if you will compare, the value of a will become 2. The value of b will also be 2. The value of k. So here, if you will see n to the power k. So what is the power term? So k is also 2. What is the value p? So here, if you will see, there is no logarithmic term that we can see. So by default, you can assume that the power should be 0. That's why its value is 1. Anything to the power 0 is 1. So the value of p is 0. So given any equation, you will be clearly able to find out the values of a, b, k, and p. Is that simple? So what is the value of f of n? N to the power k log to the power p into n. So with the help of which you will be easily able to find out these four values, a, b, k, and p. Fine for everyone? Now, with the help of these values, there comes a 3 cases which you need to understand. And after understanding of those 3 cases, master's theorem will be done. That's the simple thing. So case number 1 says, so mainly what you need to do is that in the master's theorem, you need to evaluate the value of log of a base b. Whenever you are seeing that the master's theorem is applicable, you need to evaluate the value of log of a base b. Very simple. You know the value of a, you know the value of b. For example, if I am saying for this particular recurrence relation, can you tell me what is the value of log of a base b? Who will tell me the value? So you can just put the value of a and b, log of 2 base 2, it will be equals to 1. Very simple, correct? So whenever you see that master's theorem is applicable, you need to first of all evaluate the value of log of a base b. And you need to calculate the value of k. Now, there comes a 3 cases. First case, either your value of log of a base b is greater than the value of k. Second case, your value of log of a base b is equals to the value of k. Or the third case which will be formed is the value of log of a base b is less than the value of k. Yes, these are the only 3 cases which are possible. Can I say, everyone? So what we are doing is that we are comparing this value with this value. That's it. What is f of n? F of n is this equation which I have written. N to the power k log of n to the power p. So here, if you will compare this equation, you will be able to find out the power term is something which I am referring as k. What is f of n? apart from the recursive term, which whatever function is left is called as f of n. So here k is 2 in this comparison. Whenever you will be having a logarithmic term, then only the factor p will come into picture. Whenever you don't have any logarithmic term, for example, here I am not writing any logarithmic term. For example, if suppose I will write like this, n square log of n, then what will be the value of p? If this is the recurrence relation, then what will be the value of p? Compare with this, no? Very simple. P is equals to 1. If suppose I am saying log square n, then what will be the value of p? 2. If I am not writing any logarithmic term, what will be the value of p? 0. So in this way, you need to compare the values of a, b, n, and k. 4 parameters are there. You need to understand these 4 parameters values. F of n is what? N to the power k log of np. How these terms are coming up? Experimentally, this have been found out by the researchers. So a lot of algorithms, experiments have been done to see that which particular experiment is giving us maximum answers to be correct using this theorem. And that's why this theorem is designed by a lot of, doing experiments after taking a lot of trials. They have come up with this approach. It's just one time understanding is required. After that, this approach requires a very less mathematics. You will see that there is no as a GP series which is forming up. Because if you remember, when we are solving substitution method or when we are solving a recursive tree approach, if you remember, a lot of maths is required. So if there is someone who don't know the GP series formula of doing the summation, he can't able to come up with a solution. If someone don't know sum of n natural numbers, he can't come up with a solution. So at that point of time, people raise the request to come up with one general form, one generalized form, with the help of which we will refer that theorem and we will be able to get the idea, even though we are not from a maths background. That's where this theorem will come into picture. So you will find it pretty easy. It's just for the first time when we are doing, you need to make your head open and you need to understand what is happening here. Don't get confused anywhere, right? Okay. So now we have seen that there are 3 cases which can be formed. Either the value will be greater than k, or the value will be equal to k, or the value will be less than k, right? Now, if suppose the value will be greater than k, then this theorem says that your answer will be equals to theta of, now if this is theta I'm writing, so you can write automatically in terms of big O as well as in terms of omega. Again, why it is compared with k, there is no as such reason for that. There are some things in algorithms which are experimentally done. So for those experimentations, we don't have reason. After a lot of trials, they came up with this theorem. This is a theorem. Whenever we're talking about theorem, there is no if else for that theorem. We have to understand like that only. Then there comes some other topics for which everything is having why and how. For that, we need to understand. Here, what this theorem says is what I am telling to you all. Right? So here, if you will observe, when the value of log of a base b, they are saying if it is greater than k, the answer will be equals to theta of n to the power log of a base b, as it is. Yes, theorem has proved, and it has proven a lot of times. If you will go and see the research paper of Master's theorem, you will get the proof. And apart from that, you can refer the Corman book, where in much depth everything is there about the proof I am saying. But obviously for this course, we don't want to go into that much mathematical side of the proofs, because if we have 100 theorems and we will go towards 100 theorems proof, then automatically we will be not able to cover up that DSA part, right? Which we want to cover up. So here, if you will see, the case number 1 says, so here if you will observe, now in this particular case, our value of log of a base b is 1. 1 is less than 2. What is that case which is coming into picture here? Can I say that it is satisfying case number 1? Can I say How you guys are saying yes? I don't know. This is reverse case, right? Here the value of log of a base b is greater than k. So it is not satisfying case number 1. So what I'm saying is that if it satisfies, then you will be able to get the correct answer, which is n to the power log of a base b. Let me talk about this case specifically so that you will get an understanding. For example, you will be having a recurrence relation which is equals to t of n, which is equals to 2t n by 2 plus 1. Now, who will tell me what is the value of a, what is the value of b, what is the value of k, what is the value of p? Give me the answer. What is the value of a? 2. What is the value of b? 2. What is the value of k? 0. What is the value of p? 0. Why 0? Because here we don't have any factor called n. Correct? I think it's quite easy. It's just that you have to compare it with the standard equation that we have. Now, what is the value of log of a base b? Your second task, your first task is to calculate the value of a, b, k, and p. Your second task is to calculate the value of log of a base b. What is the value of that? Who will tell me? 1. Why? Because the value of log of 2 base 2 is something which is equals to 1. Now, is the value log of a base b is greater than the value of k? Can I say? Can I say this? What is the value of this? 1. What is the value of this? 0. So this is lying under this case number 1. So if suppose someone is asking to you, what is the time complexity of this? Can you tell me now, what is the time complexity? It is theta of n to the power 1. So it is theta of n. So simple. I didn't use any substitution method. I didn't use any recursive tree approach. I got the direct answer. Any doubt? Anyone? Please ask. So if you know this approach, not in every case, only in that case where this condition is satisfying. Only in those cases where this kind of recurrence relation you have, where you will be having some value of a and b, right? What will be the worst case? If suppose I am saying that there is something which is theta of n, who will tell me what is the big O time complexity of that? What is the meaning of theta of n? Just now we studied that we already satisfy big O of n as well as omega of n. Then only you can say theta of n. Correct, everyone? Can I say? So what is the worst case? It will be big O of n only. Okay. So now let's see who will give me the correct answer. Let me talk about example number 2. For example, I am having t of n, which is equals to 8t n by 2 plus n square. Tell me the time complexity using Master's theorem. What is the value of a? What is the value of b? What is the value of k? What is the value of p? What is the value? First task done. Second task is, what is the value of log of a base b? Log of 8 base 2, 3. Now, is the value of log of a base b is greater than k? Means is the value of 3 is greater than 2? Case number 1? Yes. So what will be the time complexity? Theta of n to the power, what value you get? Log of a base b, 3. So simple. It's done. It's done. Right? So first case, I hope everyone is able to understand now. So majorly, these two steps are common for every case. These two steps are common. The third step will be varying depending upon the case you are using. So until now, we have understood only one case. And for that only I have sold you the example. Now shall we move towards the second case? So first case simply says that if this is the scenario, means if you will be able to get the value of log of a base b, which is greater than the value of k, directly write the answer as theta of n to the power whatsoever value you are getting here, log of a base b. So you already calculated that value, that number you need to write. That's it. It's done. Correct? Let's talk about case number 2. So what does case number 2 says? Now case number 2 talk about the value of p. So now when the value of log of a base b is equal to k, at that point of time you need to take care the value of p. Is the value of p is greater than -1, or it is equals to -1, or it is less than -1? If suppose it is greater than -1, and maximum number of times, if you will observe, you will get the value of p as 0. And people usually assume 0 is something which is less than -1. And they did that mistake. 0 is something which is greater than -1. So that is the case where you will lie, almost in maximum cases. At that point of time, your answer will be theta of n to the power k log of p plus 1 into n. I will talk about the examples, then you will get to the better understanding. As of now, let me write the answers. When it is equals to 1, at that point of time, it says that it is equals to n to the power k log of n. And when it is less than -1, at that point of time, it is equals to theta of n to the power k. These are the 3 sub cases for the case number 2. Okay? These are the 3 sub cases for the case number 2. Okay. Now let's talk about these 3 sub cases with the help of example, so that we will be able to get the understanding of what we have discussed here. For example, let's take one example here. So what I can do is that for the case number 2, let's talk about the examples. Example number 1. For example, here I am having t of n, which is equals to 2t n by 2 plus n. What is the value of a? What is the value of a? What is the value of b? What is the value of k? What is the value of p? 0. Now, what is the second task? To calculate the value of log of 2 base 2, which is equals to 1. So coming towards the checking of the case. Now here if you will see, the value of log of a base b is equal to k. Can I say? Because the value of 1 is equals to 1. Now, when we move towards case number 2, in what sub case it will belong? The value of p is greater than -1. Can I say? Because the value of 0 is greater than -1. At that point of time, what is the answer I am saying? Theta of n to the power k. So what is k here? 1. What is k here? 1. Log of p plus 1. So what is the value of p? 0. 0 plus 1 is 1 into n. So this is the answer. Theta of n to the power k log of p plus 1 into n. So k is 1, p is 0, 0 plus 1 is 1. Theta of n log n is the correct answer for this recurrence relation. It's done. So it's just that you should know these master's theorem, and once you will do a lot of practice of the same, you will be able to get the answer. Any doubt? Any doubt, anyone? Shall we move to the next example? Okay, so let's talk about example number 2. Now you guys will tell me the answer. Okay, I have solved one example for you. Now it's your turn. Second question. Suppose I am saying that T of n is something which is equals to 8t n by 2 plus the value of n cube. Solve it and give me the answer. Let's see who will give me the correct answer. So maximum students are saying n cube log n, but there are some students who are saying n log n. Why n log n? Justification for n log n. N cube log n, so I'll see later. Those who are saying n log n, give me the justification of that. It should be n cube log n. Why n log n? See, still I'm giving you so much simplified version of the complexities. After dealing with the substitution and the recursive tree approach, I think you might find it very easy, right? It's just we should have that chart in our head. We can solve it very easily, all the questions. Still you are doing a mistake. So here if you will see, what is the value of A? A value is 8, B value is 2, K value is 3, P value is 0. Try to solve. First step done. Second step, calculate the value of log of A base B. So it is something which is equals to log of 8 base 2. It is something which is equals to log of 2 to the power 3, 2, which is equals to 3. Now, third thing, detection of the case number. So here if you will see, this belongs to case number 2 because the value of log of A base B is equals to the value of K, because the value of 3 is equals to the value of 3, right? Now, here if you will observe, as it is belonging to the case number 2, now we need to check what is the value of the P. The value of P is greater than -1. So what is the answer? Theta of n to the power K. What is the value of K? 3. Log of P plus 1. What is the value of P? 0. 0 plus 1 is 1 into n. It's done. Any doubt? Anyone? Maximum number of time you will encounter this case only. Maximum times I am saying. Where the value of P is equal to 0. Now if you will try to understand, logically if you will try to see both of these cases, what they want to say? They want to say that in the first case, which we have discussed, anyhow calculate the value of log of A base B. Okay. And you should know the value of K. If suppose the value of log of A base B is something which is greater, for example, here we are getting the value as 3 and the value of K is 2. If suppose the value of log of A base B is greater, give more priority to this. Give more priority to this. So here I am telling you the logic of remembering these things, with the help of which I also remember these particular things. So take it like a story. What we are doing is that we are trying to compare the value of log of A base B with the value of K every time. What they are saying to me, or what Master's theorem says to me, that if suppose this value is greater, give this as a more priority, obviously, because this is bigger. So what you need to do is that you need to take the value bigger of n to the power log of a base b. Why? Because this number is bigger. Right? Simple answer. Then another case when we come across, we got the solution that if suppose we can't compare between these two, log of a base b and the value of k, they came out to be equal. In that case, what you can do is that whatsoever the value you are getting, I am talking about when the value of p is equals to 0, when there is no log into picture. At that point of time, what they are saying is that take the value of theta as it is, and what you can do is that you can say log of, you can just multiply the term. So whatsoever the value you are getting, n to the power, whatsoever the function value you are getting here, whether it will be n, whether it be n square, whether it be n cube, right? So what you can do is that you can just copy that value and multiply the term with a log of n. That's it. That's why you're getting n log n here. That's why below you are getting n cube into log n. So if both of the values are equal, what you need to do is that, and the value of p is 0, what you need to do is that take as it is that value, multiply the value with a log of n. That's it. Getting my point, everyone? What we are doing here? Everyone getting the point? Yes, we are considering the value of t of n is equals to 1 when the value of n is less than equals to 1 for all the relations. It's true. Okay, now let's talk about the another case where until now we have seen when the value of p is greater than -1, right? This case we have seen. And above case also we have talked about. This one also we have seen. What about these below cases when the value of p is equals to -1 and is less than -1? So these two cases you will see very rare. But yes, you can see. So you should know also. So let me talk about these two cases. Okay. So what we can do is that we can continue the example number 3 here, where suppose you will be having the value of t of n as 2t n by 2 plus n divided by log of n. Who will tell me what is the value of a? It is 2. What is the value of b? It is 2. What is the value of k? It is 1. What is the value of p? It is -1. How -1? If I can write this equation as n to the power n into log of -1 into n. Can I write? If I will take it up. So this is the case which you find it very rare, but still you can able to find out when the value of p is equals to -1. So at that point of time, what you can write it as? What is the answer? At that point of time, the answer is very simple. You can need to apply a log of log. So it will be n to the power k, theta of n to the power k, log of n. One more log you will be applying. So here, what is the value of k? It is 1. So the answer is theta of n into log of n. This is the time complexity of this question. Very simple. So whenever you will be getting a value which is equal to -1, at that point of time, you just need to apply. So in the above case, if you will see, our answer was theta of n to the power k log of n, right? When we will be getting a value of p as -1, you need to apply one more log here. Then that will become your answer. That is theta of n to the power k log of n. Getting my point, everyone? Let's talk about the last case, where the value of p is less than -1. Then what will happen? For example, let me talk about this example, example number 4. T of n is equals to 2t n by 2 plus n divided by log square n. What is the value of a? What is the value of a? 2. What is the value of B? 2. What is the value of K? 1. What is the value of P? -2. So here, if you will see, the value of P is less than -1. So what Master's theorem says is that when you reach towards that, when you encounter that case where the value of P is less than -1, at that point of time, the result will be simply n to the power k. There is no logarithmic term which will come into picture. So the answer will be something which is equals to theta of n to the power k, which is 1. Theta of n. Simple. So, in a nutshell, we have encountered 3 cases. Basically, whenever you will be having a log, whenever you are having a log of a base b coming out to be equal to k, we have encountered 3 cases. Case number 1, when the value of p is less than -1. And this is the most frequent case that you will be able to find out in maximum recurrence relation. In this point of time, what you need to do is that your answer will be equals to theta of n to the power k log of n. Simple. Log of p plus 1 into n, sorry. Log of p plus 1 into n, right? So whatsoever be the value, you are getting plus 1 into n. Another case, when the value of p is equals to -1. Sorry, the first case was greater than -1, right? P equals to -1. At that point of time, what you need to do is that it is something n to the power k. You need to apply 2 log there. And when it is less than -1, just now we have seen the example, which is equals to -2. At that point of time, it is simply n to the power k. So in case number 2, these are the 3 subcases which we need to make sure that you should know. Just try to visualize it. Don't cram it. You will remember. You will, when you will do practice a lot of times, even in our future sessions, we will do almost all the questions using this Master's theorem, maximum questions, because this will take a very less time and is quite user friendly. So I will try to solve maximum questions using the Master's theorem only in the next upcoming sessions also, when we are dealing with any of the recurrence relation. If we will be able to apply that, then only. So at that point of time, after getting a lot of practice and hands-on, you will be able to get an idea that which case it will belongs to. But I want to tell you that, okay, this is the way to go ahead using a Master's theorem. Case 1, example number 2, repetition of that. So example number 2, if you will see, case number 1, what we have is the value of A is 8, the value of B is 2, the value of K is 2, the value of P is 0. So we evaluate what is the value of log of A base B. It is coming out to be 3. Then we see that this belongs to case number 1. Why? Because the value of log of A base B is greater than the value of K. So at that point of time, what is the answer? The answer will be theta of n to the power whatsoever number log of A base B. So what is the value of log of A base B? It is 3. So that's why the answer is theta of n cube. Correct, everyone? Shall we move towards the last case, case number 3? So that was the last case and last part of our today's class. So let's talk about that. So case number 3 will happen when the value of log of A base B is less than the value of K. So at that point of time, you need to see the value of P. There are 2 subcases of that. Whether the value of P is greater than or equal to 0 or it is less than 0. So in case number 2, we are doing the comparison with -1. In case number 3, we need to do the comparison with a 0 number. Either it will be greater than or equal to 0 or it will be less than 0. So if it is greater than or equal to 0, the answer is theta of n to the power k log of n power p. If it is less than 0, then it will be theta of n to the power k. How? Let me give you the example with the help of which you will be able to understand what I am saying here. So let's talk about the case number 3. Case number 3. Example number 1. Suppose you will be having the value of t of n, which is equals to 2tn by 2 plus n square. What is the value of A? 2. What is the value of B? 2. What is the value of K? 2. What is the value of P? 0. Now what you will do is that you will evaluate what is the value of log of A base B. So it is something which is equals to log of 2 base 2, which is equals to 1. So here if you will observe, the value of log of A base B is less than the value of K. So it is nothing but case number 3, right? Now for this case, we need to check what is the value of P. It is equals to 0, right? So what is the answer? When it is greater than equal to 0, this is the case, right? So the answer is n to the power k theta of n to the power k log of n power p. So what is the answer? What is the value of k? What is the value of k? It is 2. What is the value of p? It is 0. So it is nothing but theta of n square is the final answer that we are getting. Here if you will observe, again, if you will observe one point, very simplified point which I want to give you here. Again, if you will see, we are doing a comparison. Comparison of log of A base B, which I was getting as 1, and the value of K, which I was getting as 2. Which is having a more priority in this particular part, case number 3? This one. So your answer is exactly, because this is having a more priority. So your answer is nothing but theta of n to the power k. Theta of n to the power k means theta of n square. At what point of scenario? When the value of p is equals to 0, or it is less than 0 also, then also it will be fine. But suppose some logarithmic term will come into picture, suppose log of square n. At that point of time, what you can do is that you can just copy the function. You can just copy this log of 2n as it is. For example, this is the question. At this point of time also, this k is equals to is having a priority. So what my function is saying, copy this function. N square log square n as it is. So algorithmically also and logically also, both of these things are making sense to us. Let me give you one more example. For example, I am saying t of n is something, example number 2, which is equals to 4tn by 2 plus n cube divided by log of n. Now, what is the value of A? It is 4. What is the value of B? It is 2. What is the value of K? It is 3. What is the value of P? -1. Now, what is the value of log of A base B? It is equals to 2, which is less than the value of K. So it lies under case number 3. We should give more priority to this case. So when you will be having a value P less than 0, answer should be whatsoever value you are getting as the numerator, theta of n cube. Answer should be theta of n to the power k. So your answer is theta of n cube. Simple point. If I will talk about in a simple sense, case number 3, what it is saying? It is saying that whenever you are getting a value of log of A, sorry, here it is log of A base B. So whenever you're getting a value which is log of A base B less than K, give more priority to that f of n. So the answer is theta of f of n as it is in general words. What is f of n? This is f of n, right? This term is f of n. So here, if you will observe again, what is the value? What is the answer? Theta of n square into log square n. Whatsoever be the function you are getting, it is as it is. If suppose there is something which you are getting as a denominator, skip that part. Only take the numerator part. Only take the numerator part. Right? So basically, in a nutshell, what we have understood in our master's theorem, see, case number 1 and case number 3 are very simple. When the value of log of a base b is greater than k, you should give more priority to this. This is what case number 1 says. So your answer will be equals to theta of n to the power log of a base b. Obviously, you should give that priority, right? Because this value is greater. Case number 3 says simply when you will compare the value of log of a base b, and if it is less than k, give more priority to this k term. So what you can do is that copy that function f of n completely. If suppose in the f of n, there is one condition, if suppose in the f of n, there is something in the denominator, so you need to skip the denominator. Skip the denominator. For example, there was something log of n in the denominator. I just skip that. I just take the upper portion, numerator part. But you need to take the value of f of n. If there is no denominator, just like in above case, completely take the value of f of n. That's it. Then case number 2 says, which is quite frequent one, where the value of p is somehow, I would say, greater than -1, which is the frequent one. It says that when the value of log of a base b is equal to the value of k, then you can't give priority to any of one cases. What you can do is that you can just copy the value of f of n, whatever you have, multiply that value with the log of n. Multiply that value with the log of n. Whatever be the value of f of n you have, multiply that value with the log of n. If suppose you will be having a value which is equals to -1, at that point of time, what you can do is that whatever be the value you are getting as f of n, multiply that value with the log of n, not single log of n. But this case you will find it very rare. So I will not I will touch upon these cases quite often. But yes, these 3 cases, which I have written down in a very short version also to make you guys rememberable, this is what it is talking about. Very simple. If you will go today at home and just try to see and observe the examples that we have covered up and the cases which I am talking about here, you will be able to understand each and everything, right? The last 5 minutes, which is a summary of all the cases, is very important. If you are not understood, go and rewatch the session again. This is what the summary is. And if you will be able to get this summary point, which I have explained in the last 5 minutes, you don't even need to remember these cases which I have written above, which seems to be complicated. This is what I have written because this is what you will see in a standard books. But this is which I am telling you just now is what is the way to remember these things. And that's what the way I have remembered those things, right? If we have 2 recursive terms, at that point of time, we can't apply Master's theorem. At that point of time, we only have an approach of recursive tree. That's the only way with the help of which we will be able to get the solution. If we have only one recursive term, that is also in the form of the way which I have talked about in today's session, that is a of t of n by b plus f of n, then only you can apply the Master's theorem. When the value is less than this, 0, theta of n to the power k. N to the power k meaning you will need to extract the value of the numerator, which I have talked about. This is the case, right? This is the case where the value of p is less than 0. So I have talked about all the examples with respect to every cases. And I think with this, the Master's theorem is completed. And with this, our module of analysis part is also completed, which was the agenda of today's class. Now in the next class, I will discuss about the array data structure. We will start with that and we'll go in very much depth towards that concept as well. So DSA live batch, lecture number 4. So this is a live session notes. Let me share with you Just go to your home, rewatch the things. Till you have any concern, please ask the doubts and clarify it whenever you get the time. My GitHub repo link is this. So this is my GitHub repo link. Okay. So one more thing. I am not sure how many people are aware about this or not. Usually on Monday from 6 p.m. to 9 p.m. in iNeuron, I used to take the doubt class. So you can join that class as well if you have the doubts of this class. We can discuss that. At that point of time, I am available. Usually what happened is that from Monday to Sunday, from 6 to 12 p.m., doubt classes are going on. Let me share with you a link. So I used to get a lot of mails by the students, and they asked the DSA questions, but from the team, but usually they told me that sometimes they will not able to resolve that. So you can just, I have shared this meeting link. You can just bookmark that as well. And if you feel like that there is something which is not clear and you want to discuss with me, you can join that class as well. Okay, to discuss the doubt. So that is the today's note. I hope it is accessible to everyone. Right? So in today's session, mainly we have discussed about the properties of logarithmic, followed by the assignment problems, which I have given to you all, followed by the concept of Master's theorem. And I hope that everything will make sense to everyone. Is this accessible to everyone? So I am not available from 6 to 12. I am available. So usually it is from Monday to Sunday it is happening, all weeks. And specifically it is happening for data science people. Okay. But because I am available, so I used to solve the data science queries there for the students. But if you have anything query with respect to this batch, DSA batch also, I will solve at that point of time. So I will be available only on this slot. I will be available only on Monday, 6 to 9. That's it, right? Not on other days or any other slot. Is this accessible? The notes which I have shared with you all? Can anyone confirm? Perfect. Fine. Okay. What else I want to give you is the practice problems for today's class. Okay. So let's talk about few practice problems. Yes, you can send me the email. I hope everyone is having the email ID, right? Either you can come in the doubt session, or you can ask the doubts in the class itself. You have so many options, right? You can ask in this session, I am saying, or you can ask via mail, or you can ask in the class before or ending of the session. So here, first question, which I want to give you all. So let's talk about few questions now. The very first question, practice problem. Problem number 1 is T of n, which is equals to 2t n by 2 plus n. Second problem, T of n, which is equals to 2t n by 2 plus n log n. Third problem says T of n, which is equals to 2t n by 2 plus n square. Fourth problem says T of n is equals to 8t n by 2 plus n square. Try to solve these 4 problems at your home, and then we will discuss in our next class the solutions for the same, just like the way we discussed today. Let me save this again because you will not get the updated file. Let me upload this file again. So that you get the updated file. And after that, I think we can end the today's class. So I think I have shared the link also for the meeting. So you can join that. And anyhow, Saturday, Sunday, so we used to meet. Fine. Perfect, everyone. If you will see, there is some mega announcement. I think just now I have received some tag on LinkedIn. So go to LinkedIn and YouTube. You guys will be able to find out the announcement. Okay. I hope that you find it pretty amazing, whatever announcements we are going to do today. Topic for next class will be, in the next class, we will start our data structures. I hope you all are excited because until now we are doing the analysis part, but now actual data structures will be starting. So we will see the data structures. What are actually data structures? We will be starting with the arrays one. Once we will be done with the array portion, after that, we will start the divide and conquer module. And there you will find a lot of exciting things, and you will see various things are very much exciting, and we will do the implementation live only. There is nothing like already code is there and I'm just explaining the code. So like that we will do. So you will also do the implementation with me, and then we will see the confidence in you. I'm very much happy until now because the way I have listened the responses today by the students, which with respect to substitution method solving or with respect to the recursive tree approach, I find it pretty amazing. And that's the approach which I want at the very end of my batch also. Okay. So with this, bye-bye everyone. Happy learning to all. See you in the next week class. Where is the announcement? On LinkedIn as well as on the YouTube. Just follow me, Krishnayak sir, Sudhanshu sir. You all know who are the mentors, right? You will be able to find out everything on the LinkedIn and the YouTube. Okay. Bye-bye, everyone.